Hey guys, if you're at home right now struggling with your factoring homework, here's a few quick notes that might help you on your factoring. Specifically using the AC method, because it's super cool. If you caught my joke there. So if we're started with a quadratic expression, ax squared plus bx plus c. Our first step in factoring this by using the AC method is to multiply your a and c. After that, you need to find two numbers that multiply to a and c, but also add to b. From there, we're going to take those two numbers and we're going to break those into our center x components. After that, we're going to take our first and second component, we're going to put parentheses around them. We're going to take our third and fourth component and we're going to put parentheses around them. After we've got our parentheses in place, we're going to bring anything out of those parentheses that we can. Once we've brought anything out that we possibly can, and it's in its most basic looking form, we're going to put it all together. Putting it all together is a little bit tricky, so let's look. Suppose we have x squared plus 5x plus 6. Now, what's our first step? Well, we need to multiply our a by our c. If we have x squared, that's essentially just 1x squared, so we can consider our a to be 1. So, a times c is going to be 1 times 6, which is equal to 6. Now, we need to think of two numbers that multiply to 6, but add to 5. What do you think those are? How about 3 and 2? What is 3 times 2? 6. That's easy. What's 3 plus 2? 5. That's easy. I think we found it. So, let's take those two numbers now and break those into our center x components. So now we will have an x squared plus a 3x plus a 2x plus a 6. And we can see that's essentially the same expression because 3x plus 2x is 5x. So that would simplify down to x squared plus 5x plus 6. Alright, after we've broken down our center x components, it's time to add some parentheses. Now, where do we add our parentheses? Well, on our first and second component, and our third and fourth component. We've got our parentheses in place. Now it's time to bring anything out that we can. In our first term, what can we bring out? How about an x? Let's bring an x out. So that'll be x times the quantity x plus 3. How about the second component? Can we bring anything out of that? How about a 2 plus 2 times the quantity x plus 3? Wow, we're pretty far. We're almost there. Now it's time to put it all together. When you're ready to put it all together and you've got it to this form, you need to recognize that your items in parentheses will be the same. In this case, it's x plus 3. So that's going to be our first component, x plus 3. Then you need to see whatever's left. Well, right here I have out front, I have an x, and then still inside I have a plus 2. So our second component is going to be an x plus 2. Wow, we just factored. So let's pretend this equals y. Equals y. This is now an equation. What are these two x values going to represent? So now we have the equation y equals x squared plus 5x plus 6, and we broke that down to y equals x plus 2 times x plus 3 through factoring and using the AC method. So how does factoring, what does this help us look at? What does this show us? Let's look at a graph. So here's the graph of y equals the quantity x plus 2 times the quantity x plus 3, or also x squared plus 5x plus 6. Now, if either one of these components, x plus 2 or x plus 3, equals 0, what's going to happen to y? Well, y is also going to equal to 0 because 0 times anything is equal to 0. So if x plus 2 is equal to 0, y is going to be 0. And what does x have to equal for that little term to equal 0? Let's look at it. Where's y equals 0? Oh my gosh, at negative 2. And when this x plus 3 component equals 0, y will also equal 0. So what makes x plus 3 0? Negative 3. Let's look at negative 3. Holy smokes, y's 0 is there as well. So that's what factoring can help us do. Factoring can help us break down a complex-looking quadratic expression simply so that we can find our intercepts where y is equal to 0.